Hi everybody, this is Mrs. Ellsworth, and what we're going to be talking about today is motion. We're going to be mostly talking about with this unit things to figure out what the speed or the acceleration or the velocity of something is. But first of all, we need to talk about distance and displacement. So distance and displacement sometimes are the same thing and sometimes they're not. So frame of reference, we need a starting point. We need something to think about that is a system of objects that are moving with respect to one starting spot. Okay, and that's our frame of reference. So the question is, how fast does the butterfly move? It depends on the frame of reference. So if I'm just sitting there looking at this beautiful butterfly and it gets off of that plant and starts flying away, with that, what a typical butterfly speed is, that's what its speed would be. But what if I'm riding past it on my horse and we're trotting around and we startle that butterfly off of there, and then comparing to the spot where I'm at as I'm moving, now this butterfly is going at different speed. So it all depends from my frame of reference. Okay, if I am sitting in a car and I see the fence posts moving by as we drive, it almost looks like that they're going backwards. Well, that's from my frame of reference. We know that they're not. We know that the car is moving forward, but it feels like it when those fence posts are just going past me. And so it all depends on your frame of reference. The frame of reference is what we use to help us figure out the distance and the displacement. Okay, so this is all about relative motion. So relative motion is very dependent on your frame of reference. So now here's our second term, frame of reference and now relative motion. This is the movement relative to the frame of reference. So now think about this. I am right now on the freeway driving and I see this other car zoom past me and I feel like that they are going like 80, 85 miles per hour. From what frame of reference? Well, because they're going past me what seems like maybe 10 or 15 miles an hour faster than me. So think about what it would be like if you were sitting still on the road and you saw a car drive past at 10 or 15 miles an hour. And so that's what my frame of reference would be. It would be what I would go and use that information to figure out how fast that car is zipping past me. So that's all about relative motion. Now think about that car that just zipped past me. I could look like I'm going backwards to them. It's all relative motion based upon their frame of reference, not mine. So here's another example. How fast is my mom moving while she's on the train? Okay, so there she's seated. So if my dad was seated at the seat right next to her, how fast would she be going from his frame of reference? What would her relative motion be? Well, it'd be 0, okay, because they're going the same speed, right? I mean, they're actually both sitting there talking to each other, so not one is going faster than the other one, and so it feels like that they're just going, that they're just right there stopped. Okay? What about from the man sitting at the train crossbar? Okay, if the train's going 55 miles per hour, guess what? It'll look like 55 miles per hour to the left or the right. Anyway, so that's from his frame of reference. Okay, and from the man on the moon, we know that the Earth is spinning fast. And so with that happening right there, and so we know that my mom would be going really fast from somebody sitting on the moon. So it all depends on the frame of reference, which helps us figure out what the relative motion is. Okay, so that will help us figure out what distance and displacement are. They are our third and fourth terms. Now distance we already know. Okay, distance is like mileage you see on your car. Now displacement, okay, this is called change in x right here. And so like if you were going to graph it, they'd be flat on the x-axis, moving away from 0 or something like that. So that's why they've got an x on that. And so that's fine. But anyways, this is the direct distance from point A to point B. Now when my family goes in a car, okay, around Alexandria, we know that we can't go straight from point A to point B, from Parker's Prairie to Alexandria, because we've got a lot of loops in the roads going around some of those lakes. Like let's say we're going to go all the way over to Menards. We've also got some blocks that we need to turn past and all those kind of things. So we don't go from point A to point B. What we read on our car is the distance, okay? But what the displacement is actually a whole lot less. Now my phone, when I look for my iPhone, okay, it'll tell me the distance and the displacement on it. And it's pretty interesting. So like when my family goes to the family cabin, it'll say it's 17 miles. But then if you go as the road, the distance, so the displacement is 17 miles, but the distance, my phone will tell me that it is 25 miles. So it's kind of interesting. Here's another example. Okay, here's a person's walking on these blocks. They're going here, 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 here. Keep on going. Okay, so they went from, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 blocks. Okay, so that's a distance. Now the displacement is a straight line from point A to point B. Oops, that's 14. Okay. That's now what would the displacement be? Well, here it is. Okay, so there is a displacement. Now that's a whole lot less than it. You would actually be able to see that you'd be going how many blocks this way, how many blocks down, and you could use Pythagorean's theorem to figure out what the displacement would be from here to there. I would never give you anything wilder than having to use the Pythagorean's theorem. You know c squared equals a squared plus b squared. We'd be figuring out c here. Okay, so that is the displacement, and you can tell that the distance that they walked was a whole lot more. And if you know your right triangles, you know that the hypotenuse, of course, is the largest side. But when you add up sides A and B, that C does not equal them this less. Just talking about your math formulas there. C squared equals A squared plus B squared. Okay, this one's on the next video. So I'll see you when I see you.